track circuit practices in non-RE area. In non-RE area, double rail track circuits are provided. A typical layout of DC track circuit suitable for non-RE territory is shown on the screen. DC track circuit in RE area. In RE area, single rail track circuits are provided. A typical layout of DC track circuit suitable for RE territory is shown on the screen. In RE area, 4 types of traction bonds are provided between the negative rails for easy path of traction return current. These are longitudinal bond, cross bond, transverse bond, structural bond. The continuity rail bond and thermic weld bond are provided at all fish plate joints for non-welded rails only. Longitudinal bonds are provided at fish plate rail joints for continuity of traction return current through negative rails. Longitudinal bond need not be provided for welded rail joints. Cross bond. Cross bonds are provided between negative rails of adjacent track. Transverse bond. Transverse bonds are provided between negative rails at every block joint. Transverse bond facilitates passing of traction return current from one track circuit to the other. It helps in detecting a block joint failure between the two track circuits. Structural bond. Structural bonds are provided between negative rails and traction structures. Continuity bond. Continuity bonds are provided at every fish plate joint. These bonds are used only for non-welded rails. Bonding practice in point zones. Series bonding. Continuity bonding provided between the rails of track circuit is in series, that is, both positive and negative rails are connected in series. Number of block joints are more, making it more reliable. As number of block joints are more, maintenance cost is high and failures are more. Parallel bonding. Continuity bonding provided between tracks is in parallel, that is, both positive rail and negative are connected in parallel. Number of block joints are less compared to series bonding and therefore less reliable. Less number of block joints require less maintenance cost. Series cum parallel bonding. This is the most widely adopted bonding practice in point zone. Positive rails are connected in series and negative rails are connected in parallel. As positive rails are connected in series and negative rails are connected in parallel, number of block joints are less. Provision of track circuit in crossover with derailing switch point zone. Number of block joints are 8. Type of bonding used is positive in series, negative in parallel. Provision of track circuit in crossover with sand hump point zone. Number of block joints are 14. Type of bonding used is positive in series and negative in parallel. Provision of track circuit in crossover with parallel movement on both sides zone. Number of block joints are 14. Type of bonding used is positive in series and negative in parallel. Provision of track circuit in ladder crossover zone. Number of block joints are 12. Type of bonding used is positive in series and negative in parallel. Provision of track circuit in diamond crossover zone. Number of block joints are 12. Type of bonding used positive in series and negative in parallel. Provision of track circuit in diamond crossover with single slip zone. Number of block joints are 12. Type of bonding used is positive in series and negative in parallel. Provision of track circuit in diamond crossover with double slip zone. Number of block joints are 16. Type of bonding used is positive in series and negative in parallel. Provision of track circuit in scissor crossover zone. Number of block joints are 28. Type of bonding used is positive in series and negative in parallel. Fouling protection. In case of track circuit in point zone, the track circuit must extend beyond the fouling mark. While marking the block joint beyond fouling mark, the extra length between wheels or axle bases to the end of buffer or coupling should be taken into consideration. If a train stands within the fouling mark, this will foul the movement of other trains. In such a case, the concerned point zone track circuit shows occupation. The point cannot be operated and the signal leading over the points cannot be taken off. Track circuit beyond signal for replacement. Provide track circuit at least 10 meters ahead of a signal. This avoids any confusion to a driver of diesel engine where driver may sit in rear. Dead section in track circuit. Dead section in a track circuit is that portion of a track in which occupation by a vehicle cannot be detected. These are due to the vehicle not shunting the rails of the same track feed polarity or due to staggering of block joints. Examples of dead section. Dead section occurs due to rail ends on crossovers being out of square. Dead section occurs due to level crossing road. Dead section occurs due to bridge or culvert under the track. Precautions to be taken to avoid unsafe condition of traffic over dead sections. Dead sections shall not accommodate a four-wheeler trolley entirely itself without shunting any live portion of track circuit at the same time. Length of dead section shall be less than minimum wheelbase length. If one trolley of 8-wheeler gets entirely accommodated in dead section, the second trolley of the same vehicle shall not go beyond the line portion of that track circuit in either direction. Trap circuit. If dead section is longer than 10.8 meter, a trap circuit shall be provided including control of dead section trap by two other track circuits on either sides. When a train coming from the left is trapped in the dead section, the BTR which has dropped cannot pick up since ATR has already picked up and CT is not yet occupied. Similarly, when the train coming from the right is trapped in the dead section, BTR which has dropped cannot pick up as CTR has already picked up and AT is not yet occupied. BTR picks up only when the train passes over AT or CT after completely clearing BT and the dead section. Once picked up, it is kept energized through its own front contact till shunts it again by a vehicle. If the last vehicle of a train gets trapped in the dead section, parting from the train and the front portion goes ahead over the track circuit in advance. This cannot be detected, but this is very unlikely to occur. Also, the vehicle trapped in the dead section of BT cannot be detected at the time of AT or BT failing.